So today I'm going to be doing a demonstration on how to find the dihedral angle in an irregular polyhedron. So an irregular polyhedron is the three-dimensional shape, which is comprised of irregular polygons. An irregular polygon means it does not have all equal sides and all equal angles. A polygon that does is a regular polygon, or as a 3D shape, it's a platonic solid. I have an example of an irregular polyhedron. This is the 3D shape. Well, it does have one equilateral square in it, which is a regular polygon. It is comprised of other irregular polygons. So altogether, it does not have all equal sides and all equal angles, meaning it's irregular. The dihedral angle is the angle that's formed between two intersecting planes. So looking at this piece of paper, when it's 2D, I have a line of intersection in the center. And when I make it 3D, you can see the dihedral angle. The dihedral angle is that V. When I'm looking at it from this way, dihedral angle is going to be right here. The reason why the dihedral angle is necessary is because when we're creating a three-dimensional shape, we need to know the angle that's between the two planes we're bringing together to make a mitered corner so that there's no overlap of material. The angle is true. With an irregular polygon, you usually begin with two sides and you need to find the third side. There can also be more than three sides meeting at a vertex in an irregular polyhedron. I'm beginning with my two sides here. I drew out two 30, 60, 90 triangles. If I were to bring it together and close the shape, I want to find out what this bottom piece is going to be. The best way we've learned to do this is to trace the angle that's created with your 3D mockup. For figuring out this equation, it's best to do everything in a mockup. It's really hard to visualize 2D, something that you're creating 3D. So I recommend getting a material that's thicker than paper, thinner than cardboard, something that's going to be sturdy, but it's thin enough to trace. You're also going to need a protractor, a pencil, and a ruler. Eventually, you want to find every angle that's within your shape. And what you do with those angles is plug it into the dihedral angle equation. That's the same for regular polyhedron and for irregular. That will give you the dihedral angles. There's going to be multiple dihedral angles because it's an irregular shape, unlike with a regular polyhedron, where every single dihedral angle is the same. So it's a little bit more work, but it's totally possible. I'm going to move to the floor to do some drawing. So I've got a piece of paper here, and I've got my mock-up, my two pieces, my two planes, and I'm going to place them onto this sheet of paper, and I'm going to draw in the angle here with pencil. Then I can go in with a protractor and measure this angle here. So I'm already going to know that this angle measured with a protractor is 40 degrees. I did these calculations before to make it easier. My next step then was cutting out the triangle that I had traced. And like with before, I wrote out what my angles are straight onto the sheet. My next step is to tape the triangle to my other ones on a two-dimensional plane. When trying to work out the dihedral angle, it's great to label each angle as A, P, C, and B. PC being the line of intersection between, and A being the angle on the end, and B being the angle on the end. I'll show you here. As I look for the dihedral angle between these two planes, I label this line of intersection P, and this here C. This is A, and this over here is B. By doing this, it's easy to plug into my dihedral angle equation, which is right here. The angle that I'm looking for is this one right here, APB. I found it by tracing out my bottom triangle and measuring it with a protractor. So right now I know that angle is 40 degrees. From here, we're just plugging things in. As a refresher, when you're looking at the angle APB, that means that P is going to be the angle you're looking for between A and B lines. So if A is 70 and P is 70 and B is 30, then APB is 70 degrees. So on and so forth for the rest of the equation. I'm going to handwrite that out in pencil on the back and rewrite the equation. Here is my equation plugged in with the numbers for the dihedral angle between two planes. I plugged in this bit here into Desmos, an online graphing calculator, and received the number 0.21. Then what I did is r-cos, which is negative cosine of that number, and received this angle right here. This is the dihedral angle, 77.9. So by way of those processes, I've just found this angle that my finger's pointing to here, which is 77.9. I know that that's going to be the same angle that's over here, and I'm just going to continue the process for the rest of the angles. When I'm ready to put in the fourth face on this, which is going to be right here, I'm going to do the same thing. I'm going to lay it down on its side, I'm going to trace it out, I'm going to measure the angles, and just repeat the process. It's going to take a bit of practice to get it, and it's going to be confusing at first. But eventually you'll get the hang of it and be able to find the dihedral angle for any shape. Then when you're ready to make it 3D, you take your dihedral angle you found and you divide it in half. That's going to be the mitered edge for both sides, and they're going to meet together to make the true angle.